Welcome learners to another session of our approximation. Decimal places are significant figure. We're dealing with a JAM mathematics session. It's taken from page 5 of our hidden fact in JAM mathematics. Let's take example. Express 62 divided by 3 as a decimal. Correct to 3 significant figures. A, 20.6. B, 20.667, C, 20.67, D, 20.7. Solution. 62 divided by 3 is equals to 20.667, which is approximately equals to 20.7 to 3 significant figure. You should try to understand how we got our answer based on the question. The question here is under JAM, so a bit advanced. You will be required to perform multiple operations towards our targeted goal. You were asked to divide 62 by 3. And when we did our division, we got 20.667. Now, is that answer we are transforming correct into 3 significant figures? And you know, we are dealing with significant figures. You talk about the first non-zero digit, and here 2 is the first non-zero digit. So you just count 1, 2, 3, and it stopped at 6. We have 20.6. But after 6, you have another 6. So we had to round up. That is why we added 1 to that 6, making it 7. That's why you have 20.7 to 3 significant figure. Another example. Correct 0.078664 to 3 significant figures. A, 0.078, B, 0.0786, C, 0.0787, D, 0.079. Solution. 0.07864 is approximately equals to 0.0787 to 3 significant figure. A little explanation of how we arrive at our answer based on what we have been treating the topic. Now, 0.07864 to 3 significant figure position will be 0.0786. Now, you know, after the 6, we have another 6. So we have to round up by adding 1 to that 6. Hence, our value where we arrive at 0.0787 to 3 significant figure. Another example. Express 49 to 3 significant figures. Options. A, 0490. B, 490.0. C, 049. D, 49.0. Solution. 49 is approximately equals to 49.0 to 3 significant figures, and not 490, as such answer will increase the value of the original problem figure. Let me explain a little further. Though we are told to express 49 to 3 significant figures, 49 is just 2 numbers. So in order to present it, to have the third number that will show that we are in 3 significant figures, that is why we introduce the decimal and then put 0. 0 after decimal does not mean anything. But if you just add the 0 there without a decimal point, what you are doing in the actual sense, you have increased the figure from 49 to 490. Another example. What is the difference between 0.007685 correct to 3 significant figures and 0.007685 correct to 4 places of decimal? A, 10 raised to power minus 5. B, 7 times 10 raised to power minus 4. C, 8 times 10 raised to power minus 5. D, 10 raised to power minus 6. Solution: 0.007685 is approximately equals to 0.00769 to three significant figures. Also, 0.007685 is approximately equals to 0.0077 to 4 decimal places. Now we subtract, we are doing the difference. That is what we are asked to do. Difference will be equals to 0.0077 minus 0.00769, and that will give us 0.00001, and that is same as 10 raised to power minus 5. Another example: correct 241.34 bracket open 3 times 10 raised to power minus 3 bracket close raised to power 2 to 4 significant figures. Options: A, 0.0014, B, 0.001448, C, 0.0022, D, 0.002172. Solution: first, we perform the little operation of indices involved. 241.34 bracket open 3 times 10 raised to power minus 3 bracket close raised to power 2 is the same as equals to 241.34 into bracket open 9 times 10 raised to power minus 6. What we have just done here is we multiply what is in the bracket, we raise them all to power 2. So that's why you see 3 turn to 9, and 10 raised to power minus 3 became 10 raised to power minus 6. Next, our value will be equals to 241.34 times 9 times 10 raised to power minus 6. Conveniently, we are multiplying 9 times 241.34, and that will give us 2172.06 times 10 raised to power minus 6. We can now proceed conveniently, changing to decimal point now, moving our decimal point based on the indices involved there, which will now give us 0.00217206. This is our answer, but we are now going to perform 4 significant figures. We correct the answer to 4 significant figures, and that will give us approximately equals to 0.002172. Another example: convert 3.1415926 to 5 decimal places. Options: A, 3.14160, B, 3.14159, C, 0.31415, D, 3.14200. Solution: 3.1415926 is approximately equals to 3.14159 to 5 decimal places. Little explanation on that. 5 decimal places after your decimal point we count. It will be at 3.14159. And after that we have 2. With 2 we cannot add anything. We round down. We cannot add anything. So hence our value remain at that 9 showing there at the last point. Another example: evaluate 64.764 raised to power 2 minus 35.236 raised to power 2. Correct to 3 significant figures. The options are given: A, 2960, B, 2950, C, 2860, D, 2850. Solution: applying the difference of two square methods to resolve our problem, we have 64.764 raised to power 2 minus 35.236 raised to power 2 will be equals to, bracket open, 64.764 plus 35.236, bracket close, another bracket open, 64.764 minus 35.236, bracket close. Now, virtually we are adding in the first case, then subtracting in the second case. So that will give us equals to 100. First bracket result will be 100. Then bracket open, the second bracket will now be 29.528. We are multiplying by 100, so we just move our decimal point to show the 2 point of movement. That will be 2952.8, which is approximately equals to 2950, to 3 significant figure. A little explanation on that. Our answer, 2952.8, being corrected to 3 significant figure. The position of 3 significant figure here is 295. But after the 5, we have 2, which is not a number 5 and above. So we round down by adding nothing to 5. But that 0 position there must still be represented because that's the fullness of the figure. Hence, we have approximately equals to 2950 to 3 significant figure.